Hello and welcome to part 8 of this tutorial series on Unity Tilemap. In the last video we used a blind walk to auto-generate our terrain and we got our character moving around that terrain, but we didn't solve the issue where we can actually move onto these blocker tiles. So that's what we're going to be looking at in this session. So let's just have a look at the code. So we'll go into the player controller, just see what's happening there. So we're calling this move player and we're passing in a direction. And then in the move player we've got a target position, which is the game object position plus a direction. We're checking if the target position is in bounds. And if it's in bounds, then we're moving the game object and updating the last move time. Okay, so what we need to do here is we need to add an additional check to make sure that the target position is a valid target position and is not blocked by a blocking tile. It still needs to be is in bounds. But maybe we don't need to call that here. Maybe we can call another function like is valid position. If you're feeling very brave, you can pause the video now and have a go at this yourself, and then I'll run through my solution after. Okay, hopefully you've had a try at that. If not, let's move on. So it's game manager is in bounds target position. I'm going to change this to game manager dot is valid position. It's complaining. We need to generate the method is valid position. So that should have, there it is, and it's under the is in bounds. So we'll make it public. Public bool is valid position. So let's do a quick if. If is in bounds target position and map data target position dot x comma target position dot y. So the interesting thing is that we check if it's in bounds here, so we don't have to check if it's in bounds in the second part, because if it's out of bounds it's not going to test this second part. So that actually works out really well for us. So if it's in bounds, is it a valid tile? Let's get rid of the negativity out there. And basically zero is something we can move on. So 2 equals that. And we're going to return true. There we're going to return false. Let's save that up. Go to the player controller, save that up. So if it's a valid position, move to that position and update the move time. Hopefully that should be enough to get this working. Let's have a look. It's compiling the C# script. Takes a bit of time. I have a sip of my tea while we're waiting. So hopefully what we'll see now is when the player moves onto these rocks, well, we hope he doesn't move onto these rocks. When we try to move onto these rocks, we'll expect it to not work. So let's just quit out of that and hit play again. So we can't go out of bounds. That's good. There's our exit. We can't go onto the rocks. That's good. Okay. So we've actually got a playable game now. And you can keep moving forward through this map. One of the things that you might find while you're playing through this is it's too easy if we can actually see the map. So the next thing we're going to do is we're going to actually hide this map and let the player discover the map as he moves. So let's have a little think about how to do that. So it's in the player controller. We need a representation of the map. So it's an int array. Call it player map. We want to make it public. Do we want to make it public? You know what? I'm changing my mind here. So many things are going to be handled by the game manager. We've got a simple game. We've only got one player, so we can do it here instead. It'll just make things easier. So where is our map data? There it is. So we're going to basically copy that and call this player map. So this is what the player can see. And in start, we're going to say player map equals new int width, comma, height. So we've got our player map in there. When we restart, that's quite important. So let's go to where that happens. Set start, generate map, clear tile map, draw map, place player. Generate map, and we're going to clear. Let's put this in generate map. Let's go to the generate map. Fill map 1, blind walk 1. Okay. Let's have those together. So player map equals new int array width height. So when we generate the map and do the blind walk, we're actually going to clear the player map as well. So that'd be all zeros again in the generate map. Now we also need another function. And that's going to be private void reveal map. That's going to take in a vector3 int. I'm pretty sure we've been using vector 3s. Yeah, we've been using vector 3s. Yeah. Vector 3 int. Should have just gone down instead of up. Reveal map. So what we want to do here actually just call this center position. So what we're actually going to do here is we're going to reveal the map around a position. So we need to have a function in here. What are we going to call that? Let me have a think. Call it site range. It's going to equal that to 2 at the moment. We'll put this into a serialized field eventually. Site range is assigned, but it's never used. We'll do a for loop for int x equals 0, x is less than width, x plus plus. That's wrong. Don't worry about it. For int y equals 0, y is less than site range, y plus plus. So let's get rid of that width there. Put in site range. So what we're going to do is we're going to set the player map. X comma y equals 1. So that basically means that we can see the player map at that particular point. Now this is a center position. So there's things that are a bit off at the moment. So site range is 2. That means we can see 2 squares in every direction. This is a center position. So we actually need to make this times 2. So it's going to start at 0 and it's going to do site range times 2. So that means we need an offset here. So we need x minus site range and y minus site range. So that's going to give us the x and the y, so that's fine. But we also need the center position. So let's take the center position dot x plus, and here we want the center position dot y minus the site range equals 1. So let's just step through that. So we've got a site range of 2. We're going to start at x and we're going to go x minus 2 at this position, the center position, and then we're going to step through until site range times 2. So that's going to be 1, 2, 3, 4 steps we're going to take. 5 steps we're going to take. So we show 5 squares at the top, then we do 5 squares down, we do a box 5 by 5 around the center position. So hopefully that's all working well. Site range I want to move. Really this should be on the player, I know. We can do a bit of refactoring later maybe. site range equals do. We better put a range on this, and it's an integer. Zero, just that 10 for now. Okay. Now we need to do a little bit of funky stuff down here. So we use F2 to change that to site range, and then we'll delete that line. So what that has done, and why I did it that way, is because it's updated all the references to site range, so they're now all point at our serialized field of 2. So we're revealing the map. So when we restart, we're setting the start, we're generating the map, we're clearing the tile map, we're drawing the map, and we're placing the player. We need to reveal map here. Ha ha ha. This is interesting because we're placing the player later on. So let's move these around a bit. So we're actually drawing the map after we've placed the player. Let's just have a look at how we're placing the player. Place player, player.transform position. Okay. Let's just copy that. New vector3 int player.transform position dot x player.transform position dot y, and that's going to be 0. It's complaining because I haven't converted these into ints. Is there a normal vector3? Okay, so we reveal a map around the player position after we have placed the player. We could have literally put in start and 0, 0 here. It would have probably been a little bit more readable, but that's a bit more. We might not place the player at that position at some point in the future, so it's better just to reveal the map about wherever the player was placed. For example, if we add the ability to save in a later video, we definitely want to be able to reveal the map around the player being in a specific position. Just thinking about that, when we do the save, hopefully we'll also save the player map that's been revealed. So cool. So we're revealing the map. Now we need to draw the map. So we're going through the whole map, and if the map data equals 0, we're going to get a random tile. Else, if the map data equals 1, we're going to get a blocker tile. That's interesting. You might want to pause now and give yourself a challenge to implement this drawing of the map now with the player map behind it. So I'll just give you a couple of seconds to pause. Okay, hopefully you've had a try at doing this yourself. If not, let's just run through what we're going to do. So we're going through the map, and the first check that we're going to make is if player data sorry, it's called player map, isn't it? Player map x comma y equals 1. So if it's visible, then we're going to draw it. Is that enough? If the player map equals 1, then we're going to draw it. Tilemap.setTile, tilemap.setTile. So what's interestingly going to happen here is every time it draws the map, it's going to get a random tile. And we don't want that to happen. So if player xy equals 1, and we get an and sorry, and tilemap dot get tile let's have a look what we've got here. We've got an XYZ. New vector3 int x comma y comma 0 does not equal null. Now it's complaining there because I've put that in the wrong place. So we're actually going into the tile map and seeing if it's already been drawn. So if it's already been drawn, that will not be null. So we want it to be null. So if it's visible and it's null, then we get a new tile. If it's visible and it's null, then we draw a new tile. Yep. That makes sense to me. I hope it makes sense to you. Let's save that up. Now we're going to have to draw this map every time the player moves. So let's just have a look at our move player. Okay, we could do lots of funky things here. But just for the sake of simplicity, let's not have too many new things. We're going to make this a public void. Draw map. And we're going to say game object dot no, sorry. We need to reveal the map as well. So where did we put that down? Reveal map needs to be public. So we're going to go, this is not the way to do it, but this is the way we're going to do it, just quick and dirty. Game manager dot reveal map. target position. That works out nicely. Game manager dot draw map. That doesn't need a position. So we're going to reveal the map around the player, then we're going to draw the map. Let's save that. And if by some miracle that all works, we should be able to not see portions of the map until we explore them. Okay. Oh, and then it draws it. Oh, and then it draws it. It's not supposed to look like this, guys. Something's gone horribly wrong. So let's do a bit of debugging. That's fixed itself up. So let's create a breakpoint here, and we're going to debug. So just a couple of things. You need to make sure you've got the debugger for Unity downloaded in your extensions. So get that. Then you need to create a JSON so you're able to use this. This is explained in other videos when we're setting up and installing the installing Unity. So you can go back and have a look at that video if you haven't done this before. But we're going to start debugging. That started. And we're going to go into the code, go into the game, sorry, start the game. Hold on. So it should break. Unknown identifier, get width. Evaluate request failed, unknown identifier, get width. It's interesting. So it stopped. So first thing we're doing is placing the player. Then we're revealing the map. So we're passing in the player transform position .x and the player transform position .y and a 0. Center position .x, center position .y minus sight range. Somehow we managed to get rid of our plus y here. Center position .y plus y minus sight range. Let's see. So I think we found our problem. Let's stop. Just compiling. If you want me to do like an in-depth video on debugging in Unity and debugging in C# with the Visual Studio Code, do let me know in the comments below, and we can do a session on that in more detail. debugging, you'll probably spend more time debugging than you actually spend writing code. Well, if you write code like me, you will. Anyway. Okay, so that's interesting. Let's get rid of my breakpoint. Index was outside of the bounds. Ha ha ha. Yeah, we do something very naughty here. So back into our game manager. We're being very naughty. So what we want is an integer, which is we're going to call exposition. Exposition equals all of that. And then we're going to have an int. We're going to call this y position equals all of that. Not that. X. Y. And we're going to have an if. House points, if you can guess what I'm going to write now. If is in bounds. New vector 3 int x position, comma y position, comma 0. Yeah, so we don't basically want to try and set something in the player map that's not within the bounds of our map. So this is in bounds check, it's very important. It also helps a bit just to see this difference. So that's just x and y. That should be x position and y position. Okay. Did I save everything? Yes, I saved everything. Ooh. It's interesting because it hasn't gone far enough up. And it hasn't gone far enough across. It's very lopsided, isn't it? Okay. Okay, so if you look in our little for loops, we start at 0 and then we want to go up to 5 steps. So that's up to 4, but this is a less than here. It should be a less than or equal to. Let's save that up. Okay, and press play. It should all be working now. That's looking good. Okay, let's make this a little bit more interesting now. So if we go into our game manager and our height and width, and let's expand that. Let's just do 16 now. 16, 16. Let's put an extra 0 on our max steps because we're increasing the size of the map. So now we have our world to walk around in. Oh, dead end. Oh, I can go up here. Oh, I can go up. I can go up. I can go up. I can go up. We're at the top of the map, but we still haven't found the exit. There's the exit. And we could go around and explore more of this map and reveal it sort of along the way. And when we go to the top of the screen, it generates our new map for us. And we're away again. Brilliant. So this is where I plan to leave this series of tutorials for now, and I'd just like to hear back from you what you would like to do in the future, whether it's expanding on this tutorial or whether it's a completely new series of tutorials. So we've learnt a lot. We've learnt how to use source tree and Git for version control. We've learnt how to use tile maps, how to interact with tile maps with a tile palette, how to interact with the tile map actually in game with the mouse. We've auto-generated terrain, and we've looked at weighted randoms in order to do that. We've got a character moving around our auto-generated maps. We've also got a feature where we can sort of reveal hidden terrain as the character moves around the map. So we've actually done quite a lot of things so far in this series. A couple of challenges for you. I think you could probably have a lot of fun refactoring the code. It's certainly not best practice. You might want to have something that's more event driven. You might want to create some more classes to handle different things. So if we've got a game manager, we could have a map manager, and we could certainly make it a lot sort of better architecture. So at the moment, the game manager needs to know about the player, and the player needs to know about the game manager. It's all very sort of mixed up. So challenge one is refactoring the code. So it's just a lot more sort of clean and readable, and it functions well. It does the job at the moment. You might want to add in some pickups. For example, you could add food, and you have to collect enough food to be able to explore the map and to escape at the top of the map. You could add enemies onto the map. You could have a much larger map and use a second camera to show sort of a mini map in the corner. These are some of the things you can think of. I'll put these challenges into the blog on the gamedevsteps.com website. So do have a look at that website, and if you've liked this tutorial, please subscribe to my channel, and please put some comments down there below. Thank you very much, guys. Bye.